Okay, welcome back everybody. Now we're going to kind of put together all the pieces that we've learned so far to graph a rational function. So this is kind of a long 5-step process. It takes a little while, but each step is actually pretty easy. So what I did was I put a box here for each step, 1 through 5. Find the Y-intercept, find the X-intercept, find any vertical asymptotes, find any horizontal asymptotes, and then plot some points and fill in the curves. So we're going to kind of walk through this in example 5 here. So let's say that we have this rational function, f of x equals 6x minus x squared, 6x over x squared minus 4. And the first step is to find the y-intercept. So the y-intercept, to find that, you just plug in 0 for x, right? The y-intercept is where x is 0. So f of 0 is going to be 6 times 0 over 0 squared minus 4. Well, 6 times 0 is 0, so I'm going to get 0 over negative 4. 0 over negative 4 is 0. So what that tells me is that 0, comma 0 is my y-intercept. Intercept, okay. Next step is to find the x-intercept. And to find the x-intercept, you set y equal to 0. So that would be f of x is equal to 0, which is 6x over x squared minus 4. And so if you multiply both sides by x squared minus 4, this equation becomes 0 times x squared minus 4 equals 6x times x squared minus 4 over x squared minus 4. And of course that'll be 1. So this is just taking some number and dividing by itself, right? So we'll cancel that part. So then we get that 0 is equal to 6x, because 0 times x squared minus 4 is still 0. 0 times anything is 0. Divide both sides by 6, and you'll get that x equals 0 is your x-intercept, which I guess, you know, if we thought about it, we could have just said the x-intercept is going to be the same as the y-intercept because it's 0, 0 in this case. But this is the surefire way of finding the x-intercepts. Okay, so there again, the takeaway is that 0, comma 0 is the x-intercept as well. Okay. Step 3 says to find the vertical asymptotes. And if you remember to find vertical asymptotes, what you do is you take the denominator and you set it equal to 0. So the denominator here is x squared minus 4. So x squared minus 4 equals 0. If and only if x squared equals 4. That's just adding 4 to both sides. And then we're going to take the square root, and so we're going to get x is equal to plus or minus the square root of 4. Or x is equal to plus or minus 2. Okay? So those are my vertical asymptotes. And highlight those in green. Okay. Finally, we need to find the horizontal asymptotes. And to do that, you look at the degree of the numerator over the degree of the denominator. So since f of x is equal to 6x over x squared minus 4, we're looking at the degree of the top, which is 1, divided by the degree of the bottom, which is 2. Okay, so degree of 6x is 1, and that is less than the degree of the denominator, which is x squared minus 4, which is 2. Okay? So since the degree on top is smaller than the degree on bottom, the bottom is going to grow much faster when x gets big. So that tells you that, that the horizontal asymptote will be 0. Okay, so this is going back to our previous table. So y equals 0 is the horizontal asymptote. Okay. So once you have the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptotes, you can plot the horizontal asymptotes as like dotted lines in the graph, like I've done here. So I got x equals negative 2 and x equals 2 are my vertical asymptotes. My horizontal asymptote I'll draw as a dotted line in teal. That's y equals 0. And again, that's behavior of the graph when x gets really big and negative or really big and positive. So this is y equals 0 is the horizontal asymptote. x equals 2 and x equals -2 are my vertical asymptotes. Okay, so those are the lines the graph won't actually they won't touch the green lines, and they may touch the turquoise line, but only in the middle of the graph. When x gets really big, it'll just approach it. Okay, the final thing to do is to plot some points. And so you want to plot some points, or pick some x values to the left of -2, to the right of -2, to the left of 2, and the right of 2. So I'm going to pick -4, -1, 1, and 4. And you could pick many more points, but let's just start with these for now, and then maybe we'll add some more if we need more data. Okay, so if you plug in -4 in for x, then for y you'll get 6 times -4 is -24 over 4 squared is 16 minus 4. So that's -24 over 12, or -2. Okay. If you plug in -1 in for x, you'll get 6 times -1 over -1 squared minus 4. That's -6 over -3, so that's +2. Okay, so what I found so far is that -4, -2 is a point on this curve, and -1, +2 is a point on this curve. Of course, my y-intercept was 0, 0, so I should plot that too. Okay, and then if I do 1, I get 6 times 1 over 1 squared minus 4 is 6 over -3, or -2. Okay, so 1, -2 is also a point. And finally, if I plug in 4, I'll get 6 times 4 is 24 over 4 squared minus 4. That's 24 over 16 minus 4 is 12. So it's +2. So it tells me that 4, +2 is also a point on this curve. And now you might want a little bit more information. So let's try plugging in like -3. If I plug in -3, I get 6 times -3 over -3 squared minus 4. So that's -18 over 9 minus 5. Minus 4 is 5. So that's -18 over 5, which is like, you know, roughly -3 and 3/5. Okay, that'd be like, so that says that -3 would be somewhere down here. So that's -3, -3, and 3/5. And if you keep on plugging points, like if you plug in +3, you'll get +3 and 3/5. Maybe you want to keep on plugging more points, but I have a pretty good idea of what this graph looks like. Because I've had some experience graphing these things. It's going to look something like this. And if you keep plotting points, you'll find that it's going to look something roughly like the following. You have a line that becomes almost horizontal when x becomes really big and negative. It becomes it has a vertical asymptote at x equals -2, and so it does something like this. Okay, and then finally, again, you have a vertical asymptote at x equals 2, and it kind of jumps size from positive to negative. And finally, it starts approaching my horizontal asymptote again, which is y equals 0. Okay, so if you had any doubt, you could just keep plugging in points, and then you'd have more dots to fill.